Today we're going to be looking at corresponding parts of similar triangles. So we're sticking with the ideas of similar triangles, but there are some other parts of triangles that are also going to be proportional to each other. First, I want to do a quick review. We have these terms over here, altitude, median, and angle bisector. We need to remember what each one is. Angle bisector, usually everyone's pretty good with, cutting the angle in half. The median, if you remember, goes from a midpoint of a side to the opposite vertex. And an altitude meets the opposite side at a right angle. Okay, so we're looking for the right angle. So in these pictures here, my angle bisector here is in the middle. My median is going to be on the far left. My altitude then is down here below. Okay, so that was just a quick review of those terms. So the first conjecture we're going to look at today says that if two triangles are similar, then their corresponding altitudes, medians, and angle bisectors are all proportional to the corresponding sides. So meaning if I had, let's say in this case here we have medians. Okay, so we have medians of triangles there. And let's, again, make this easy. So let's say this is 5 and this is 10. And if I knew my median, in this first triangle is 4, I can solve for the second one because they're all proportional. So I can do 5 over 10. So the side of the left triangle over the side of the right triangle equals the median of the left triangle over the median of the right triangle. Okay, now granted I made this easy, but we can cross multiply. You have 5x equals 40, divided by 5, I get x equals 8. Okay, so that median there would be 8. So same rules apply, just like when we were solving for missing sides of triangles, but now we can do it for the altitudes, we can do it for the medians and angle bisectors. Okay, so I'm going to give you a minute here to look at this problem. It says the two triangles are similar, so we've already established the fact that they are similar. It says M and N are midpoints. So if M and N are midpoints, that means that RN and BM then are going to be medians. Okay. Then I want you to find the values of H and J. All right, so keep in mind H over here is actually part of an altitude, but it's still, the idea still holds. So I'm going to ask the substitute to go ahead and pause the video for a minute, let you work through this problem, solve for H and J, and then when you guys are ready, she'll hit play again, or they'll hit play again, and then you'll be able to check your answers. Okay, so now that you've had time to look at the problems, let's start with the altitudes. Let's start with H. So solving for H. All right, so we know the triangles in relationship of 1.2 over 3.2. So I just did top triangle to bottom triangle. Solving for H would correspond with 2.4. So then I'm ready to cross multiply. So 1.2 times 2.4 gives me 2.88. So 3.2H equals 2.88. Divide by my 3.2. I have H is equal to 0.9. Okay, now let's go through that same process and solve for J. All right, so again, I'm going to use the 1.2 to 3.2, the top to the bottom. And now I'm just going to compare 1.5 to J. So I have cross multiply, I have 1.2J equals, multiply 3.2 times 1.5, I get 4.8. So J is going to be equal to 4. All right, the next conjecture says that if you have an angle bisector, okay, so if we have an angle bisector, so in this case we have these two angles that are congruent, that angle bisector divides that third side into two parts. Okay, we have a part 1 that goes from here to here and a second part that goes from here to here. Okay, what this conjecture tells us is that there's a ratio that happens here that we can use in order to solve for missing parts. So I'm going to go ahead and label, oops, I missed a letter there, A, B, C, and D. Okay, so this conjecture says that the leg over its part of the third side, so A over B, is going to be equal to the other leg, D, over its part of the third side. So A over C. Okay, so just stop and look at that for a second. The leg here over its part of that third side is equal to the other leg over its part. Okay, and this only happens when you have that angle bisector. So the leg over its part equals the leg over its part. What I'd like to do is take a minute and prove to you why this works. So just, you don't have to write this down, just sit back and watch and relax, and we'll go from there. All right, so what I'd like to do is prove that AB over BD is equal to AC over CD. Okay, so I'm just proving the leg and its part is equal to the leg and its part. All right, so first thing I need to do, this is not the most obvious proof in the world whatsoever. In fact, it's pretty advanced. So one thing we need to do here is actually extend this angle bisector. Oops, I'm going to draw that as black. Okay, so there's my angle bisector. Let's go ahead and mark our congruent angles there. Hey, I'm also going to construct a new segment here that is parallel to AB. I'm going to go ahead and name this point down here E. Okay, so I've constructed a line that is parallel to AB. Now, because I have parallel lines, I've now just created some alternate interior angles. So the angle up here at A, the angle up here at A, and the angle down here at E are going to be congruent. Okay, now, the reason I wanted to do that is because I've now created, because of the vertical angles there, I've now created two triangles that are similar. So we're looking at this triangle here and this triangle here. These two triangles are going to be similar now because of angle. So let's talk about parts that correspond here. I want to know, keep in mind, my goal is this part up here, right? My goal is this proportion up here. So what I want to do is compare AB. So AB, oops, let's color this. AB compares to, if I look down at this other green triangle, AB matches up with EC. Now, granted, that's not what I want, but we'll get there. Okay, then AC is not part of my, excuse me, my green triangles there, but CD is. Okay, so CD is part of that lower green triangle. So let's go ahead and list that. CD would match up with BD. All right, now, a lot of this actually looks pretty okay. I would like BD here. Since BD is on the bottom here, I'd like BD to be on the bottom here. Okay, now if you think about your algebra, we know that terms that are diagonal can actually trade places. And when I say trade places, what's happening is I would multiply this side by EC, multiply this side by EC, so it'd be in the numerator. Divide both sides by BD, so it'd become in the denominator. So I'm going to rework this a second. We're going to take AB, AB, I'm going to swap out BD and EC. All right, so now we're a lot closer to where we are, where we want to be up here. My problem is I want to get rid of EC. I'd really like to replace that with AC. So what I want you to do is I want you to focus on triangle AEC. Focus on triangle AEC. Okay, notice that at angle A and at angle E, we have 1 tick marks on our angles. That means that triangle AEC is actually isosceles. It's actually isosceles. So that being said, I know that AC and EC are congruent. So since AC and EC are congruent, I could replace EC with AC. Whew, okay, so really what happens here is that these are the two triangles that are similar, but because the parts that are shared and parallel lines and isosceles triangles, we end up having a proportion that we can use. All right, so let's stop and let's just practice it. Okay, Okay, so in this triangle, we have two triangles, or I'm sorry, in this problem, we have two triangles that are similar. I want you to solve for all these missing pieces. Okay, again, I'm gonna have you, the substitute, go ahead and pause the video, and then solve for your parts, and then I'll walk you through all the answers. Okay, so let's go ahead. I'm going to solve for WX first. So I'm going to solve for WX first. All right, so when I solved for WX, I did 28 over 16. And where I got that from was the AC here, 28 over 16 equals 24 over, I'm just going to go ahead and put WX. So I'd have 28 times WX equals 384. When I cross multiply, divide by 28, and I'd have WX is equal to 13.7. Okay, and we'll go ahead and list that down there below on my figure as well. I try not to use that because if it's wrong, then all my answers are going to be wrong and I build off of that. But I'm going to go ahead and fill that in for now. All right, let's do DB. I'm going to do DB next. So DB, I'm going to do my DB. This is this rule we just learned, the angle bisector theorem. So I'm going to do AC over CD, so the 28 over 14. No, I'm sorry, I'm doing the wrong one. DB, okay, I'm sorry. So AC over CD, and then AB over BD. So the leg over its part equals the leg over its part. So I did 28 over 14 equals, 24, it's supposed to be 24, over DB. Cross multiply, you can probably see the pattern there anyways, but it would be X equals 12, or DB, I'm sorry, equals 12. So I know this piece here is 12. I'm going to go ahead and write it in up here as well. Okay, XZ. XZ. So we're looking at this piece right here. Okay, so what I'm going to do is I'm going to do sides that I know for sure. I'm going to use my 28 and 16 again. I'll use that as my ratio. And then I'm going to set up, compare that to DB to XZ here. Okay, because those are going to be proportional parts as well. All right, so XZ. I have 28 over 16 equals 12 over XZ. Gives me 28XZ is equal to 192. So XZ is 6.9. I'm going to write that in, 6.9 there. XZ up here is going to be 6.9. And honestly, that should really make sense, because if you think about when we were looking at the legs and its parts here, 24 and 12, that's half. 12 is half of 24. 28 and 14, that's half. Okay, think about WX. Okay, WX is 13.7. About half of that is about 6.9. Okay, so what do you think YZ is going to be? If this is 16, this is going to have to be half of that, or 8. Again, I could set up a proportion. I could do 28 over 16 equals 14 over my unknown, but follow that pattern and you should get 8 for that as well. So YZ here is 8. Last thing we have to do is solve for the that angle bisector there. So we're going to solve for the angle bisector. So I did, let's see, we had 28 over 16. So again, I went with the ratio that I know, equals AD over 12. So I have AD equals, 16 times AD equals 336. Divide by 16, so AD is going to be 21. Hopefully that wasn't overly confusing. Okay, your homework then is out of your book. It's on page 588, 589, numbers 1 through 13. Go ahead and work on that. You may also work on your cookie cutter projects if you need the laptops, or sorry, the Chromebooks, go ahead and get those. Don't forget, you have to have through the design process done by the end of the day today. I will start grading those tonight. So whatever you have done tonight is what I'm going to take.